Hi, my name is Gerhard Klimek. I'd like to share with you what nanoHUB is doing for semiconductor education and workforce development. Let me start out by just summarizing who is coming to the site. We have over 2.1 million users. We have over 2,400 contributors, and it's typically students and faculty that come to the site to learn about semiconductors and nanotechnology. What is there? We have over 700 apps that are running in the cloud, over 6,500 lectures and tutorials. We have over 170 courses in this area. We are a MOOC. I'll show you how we calculate and determine that we have over 89,000 students that come in classes and use these apps. And I'll show you how rapidly we can change curriculum and introduce applications. These apps are now listed in the Web of Science and the Google Scholar as a new type of publications. And we also measure impact on research. Now, if you click on this banner here, you'll get to a dedicated group page that talks about semiconductor workforce development and the content that we provide through nanoHUB. And I'll talk about immersive learning through simulations quite a bit. We have open courseware available in a variety of topics, and this is just a selected list as an editorial list. So if we look at education, we also note that the typical semiconductor books that we use today really follow 60-year-old SEEK notes. And Mark Lundstrom has been pushing for developing new approaches. And we have several textbooks freely available that really are new views of semiconductor devices and related topics. We also have these 600 apps I mentioned that are in electronics and materials. We have tools that require more expertise and more learning curves, so they're not just apps. We also have commercial software in a growing array. We have a large set of curated educational resources, and we have continued engagement with faculty, and I'd like to highlight that next. And that specifically, I want to talk about semiconductor device fundamentals, and we have assembled a tool set for that covers crystal structures all the way to MOSFETs. And we have over 16,000 users of this tool alone. And starting in December, we had recitation sessions dedicated to faculty. There's 181 individual unique faculty that participated in the 6 sessions so far, 46 on average. And what do we demo to them? These are some examples here of the modern crystal viewer and the PN Junction Lab, and I'll talk about PN Junction Lab also in a second. So the question now is, how do we know how many people are coming to the site and what they're doing? We do this through data analytics and user behavior. In fact, we've developed cluster algorithms years ago that identify these people that are behaving in a similar fashion through the time and days here. And we can stack them up, we can measure classroom sizes. And as I mentioned, we've detected over 89,000 students that use these apps and courses. Now, how fast can you change curriculum? Since each of these tools is a publication, it has a DOI, it has a birthday, I can measure the first time until they hit the classroom. And I want to compare that time to 3.8 years, which is the average time of writing a textbook update. And what we find is that the median time is less than 6 months. We can change curriculum very fast. The last thing I want to cover here is, what do these classes actually do? And I'll walk you through one example here with PN Junction Lab. You hit simulate, you get band-edge diagrams, you change doping, you hit simulate, you get another band-edge diagram, you can hit all and compare these band-edge diagrams. And what I've done here is really run 2 experiments, so to speak, in one tool that are asking what-if questions. The question now is, what do students really do in the classroom? And I'm comparing specific 2 populations, 2 different classes, different locations, roughly the same size and number of runs. And they can change 10 parameters, and class number 1 does this, and class number 2 behaves quite differently. And we're starting to engage with faculty members to try to provide feedback as to what the students really do as they learn about semiconductor devices, which gets me back to the landing page of nanoHUB being the online resource for semiconductor workforce development. And I hope you visit the site soon. Thank you very much.